A few students had questions about end behavior. So end behavior is just talking about what's happening with my function at the ends, for lack of a better term. Now, of course, we know with something like a polynomial, the domain is x is an element of the real numbers, so the graph goes on forever in both directions. But we just want to know what's happening to the y values as x gets really small. So as x gets smaller and smaller as we travel to the left on the x-axis, what's happening with y? In this case, it's getting larger and larger and also approaching infinity. And as x gets bigger and bigger and bigger, so as it goes further and further over the graph to the right, what's happening with the y? Well, in this case, again, it's going off to infinity. So there's a little bit of new notation that you have to learn, but the good news is there's only 4 different cases that you have to learn. So the possibilities, if you have an odd degree, so what I mean by the odd degree is just look at the highest power and the exponent on that power, and if it's an odd number, then it's an odd degree. So x to the 1 or just x, that would be an odd degree. And it doesn't have a positive leading coefficient, so if I have just a 1 in front, it's positive. Then we can think about what's happening with just the line y equals x, and the end behavior will be the same for any, even the more complicated odd degrees and positive leading coefficient cases. So in this case, here's my line, y equals x, and as x approaches infinity, y is also going off to infinity. It's going in the positive direction. And as x goes off to negative infinity, y is going off to negative infinity as well. So the big thing here is that the end behaviors do not match. The arrows are pointing in opposite directions. And because it's positive, as x goes to infinity, y also goes to positive infinity. And this is the notation you would use to write your answer. Okay, so if there's an odd degree, so you're looking at the power with the largest exponent again, this one again is just a 1, and you have a negative leading coefficient, so a negative 1 out front here, then your end behavior is still not going to match because it's odd, but it's going to be flipped over. So a line with a negative slope is an easy way to think about it. So as x goes to positive infinity this time, y is going to negative infinity. It's decreasing as x goes to positive infinity, and as x goes to negative infinity, y goes to positive infinity. So it's just the opposite of what we saw in the last case. But again, end behaviors do not match. They're pointing in opposite directions. And then if I look at more complicated odd degreed functions, what you can see is that the end behavior would be the same. So this one is an odd degree and a positive leading coefficient. So it's exactly the same as the simpler case above. As x goes to infinity, y goes to infinity, and as x goes to negative infinity, y goes to negative infinity. And the case with an odd degree and a negative leading coefficient, it's just flipped. It's the same as the case of the line with the negative slope. So as x goes to infinity, y goes to negative infinity, and as x goes to negative infinity, y goes to positive infinity. So one thing to note again is that these do not match when it is an odd degree. A lot of times people aren't sure what to do with the x. You every time have this. This does not change. It's just what's happening with y that changes for the end behavior. Okay, let's look at the case of an even degree. So for an even degree with a positive leading coefficient, something like y equals 1x squared would fit that bill. We want to look at what's happening. Well, the end behaviors are going to match. And as x goes to positive infinity, y is going to infinity. And as x goes to negative infinity, y is going to positive infinity. So this time, you want these to match. Okay, and if it's an even degree with a negative leading coefficient, think of a concave down parabola like y equals negative 1x squared. As x goes to infinity, y goes to negative infinity. And as x goes to negative infinity, y goes to negative infinity. So with even degrees, You're looking for those arrows to be pointing in the same direction and the end behaviors to match. If you look at more exciting examples, like y equals 2x to the fourth plus 2x plus 3, the end behavior here is exactly the same as the end behavior for y equals x squared. So as x goes to negative infinity, y goes to infinity. As x goes to infinity, y goes to infinity. End behaviors match, and the arrows are pointing in the positive direction. In the example where you have a negative leading coefficient in even degree, as x goes to negative infinity, y is going off to negative infinity. And as x goes to positive infinity, y is going to negative infinity. So again, these behaviors are matching. These never change. This is always a standard statement. You're just saying as x goes to infinity or negative infinity, what's happening with y. And the arrow is really important. The arrow means it's approaching. You can never reach infinity.